Okay, one more talk to go. I'm Eric Tomusk. I'm here to give you an update on SYCL SC. So that's SYCL for Safety Critical Systems. And by way of introduction, today's presentation is a follow-up to last year's presentation here at IWOCL. And you can catch up with that on this YouTube link. The very short version of today's presentation is that over the last year, we've had an exploratory forum in Kronos to investigate the demand for and the scope of SYCL SC. If you haven't heard of one of these before, an exploratory forum is a mechanism that Kronos uses to investigate whether a new standard is required. And in this case, the exploratory forum was attended by both companies that are already Kronos members, as well as companies that are not yet Kronos members. So the exploratory forum produced a statement of work. This was approved just in March, and that means that the exploratory forum has now concluded and no longer exists. And instead, there is an official SYCL SC working group. And you can see we have an official logo there as well. So as part of introducing a new working group, there was a press release, and a number of companies came out to express their support for the working group. And some even gave us quotes. And you can catch up with all the details at on the Kronos website. So this is all to say it's very exciting times for SYCL SC. But back to today's presentation, what I will be telling you about is a little bit of the background of SYCL SC. And I'll give you an overview of the exploratory forum's activities. And then because we have quite a technical audience in the room, I've picked out some technical details that I can share with you. And then finally, I'll conclude. This does come with a few caveats. So I'm here speaking as a CodePlay employee who was involved with the exploratory forum, and I will continue to be involved with the working group. However, I'm not representing Kronos or the exploratory forum or the working group. And that's just saying that my opinions are my own. Also, yes. Also, I need to point out that the exploratory forum was held under an NDA just to make sure that the companies that came along were able to speak more freely if they wanted to. And that means that I won't be telling you too much about the specific details of the discussions. Instead, I will share some of my own lessons learned and some of my own impressions and a little bit of my own research as well. Okay, so let's get to some background. So we're talking about the SYCL for safety critical systems. And first off, what I need to do is define this term safety critical for you. And in the context of software, whenever we say safety critical, it really means any domain where if the software malfunctions, there could be serious damage to people, to property, or to the environment. And there are a number of domains that come under this umbrella. Automotive and aerospace spring to mind, but there's actually quite a long list. So then when we're thinking about introducing SYCL into these domains, the immediate question you might ask is, why SYCL? And I think to answer that, it helps to take a step back and remind ourselves why SYCL exists. I think for the audience in this room, this will be very familiar to most of you, but I think it's helpful for me to just blitz through it very quickly to make sure that we're all on the same page. So as we all know, there are lots of accelerators out there. There are lots of low-level APIs to program these accelerators. And the reason we have accelerators is because they are much faster than CPUs for some tasks. Examples of accelerators include FPGAs and GPUs and all of that. And there are a number of low-level APIs used to program these. Some of these are Kronos standards, some come from other parties, some are proprietary. The problem with these low-level standards tends to be that they are quite verbose, they are quite complicated. And if you're using one to develop something, you really benefit from a detailed understanding of the underlying hardware. Meanwhile, the whole reason we even have a software stack at the end of the day is because what we want is applications that do useful things for us. The problem there is that application developers at the moment, the way the industry is, they very much want to use hardware accelerators, but they are domain experts, not hardware experts. And that means that in general, applications get developed up on top of domain-specific frameworks. And what I mean by that is if you're writing a machine learning application, you're not going to sit down and write a whole bunch of convolutional neural network math code. You're going to use something like PyTorch. But then the framework developers have the same problem, that they are domain experts, not hardware experts. So we end up with this abstraction gap between low-level APIs and application frameworks. And this poses a few problems. The first is, if you're going to implement your framework, you need to be both a domain expert and a low-level API hardware expert. And that's just a very tall order for one person to have all that information in their brain. The second problem is that this would require re-implementing the same framework on a number of different low-level APIs, and that's a lot of redundant effort. So this really is the value proposition of SYCL, that it's C++, so it's reasonably familiar. It abstracts away a lot of the low-level details, and it has various developer quality of life features. So if we think about a normal, not safe software stack, this slide really summarizes a big part of why SYCL exists. So then if we think about a safety critical software stack, the story in the industry at the moment is very similar. We have accelerators on the left. We have low-level APIs. The names of these APIs are a little bit different from the ones you might be used to, but the underlying intent of them is the same. And then on the right-hand side, we again have application developers who would really like to access the hardware accelerators. In safety critical applications at the moment, there's also an adjacent concern that what they would really like is to have more portable applications. And that hasn't been as much of an issue for safety critical applications in the past. So again, we have this abstraction gap between application frameworks and low-level APIs, and this poses all the same problems to safety critical software as it does to normal software. In addition to that, safety critical software requires that the whole stack be certified. So there's an added certification overhead. And if what you're trying to do is certify a number of different implementations of the same framework on various low-level APIs, that certification overhead becomes unviable. And that means that there are frameworks we would like to have that we just can't have. And this is where the value proposition of SYCL SC is, that we think that a well-designed API at this middle spot in the software stack can reduce the certification overhead for this whole software stack. And that means that it can make safety critical applications and frameworks viable where they weren't viable before. So then looking at this stack, a question that might come to mind is, why do we need SYCL SC for this? Why can't we use the SYCL that we already have? And there are layers of answers to this question, but a lot of this has to comes down to safety critical processes. So if you're developing safety critical software, you need to make sure that it's developed based on an industry process. Depending on what domain you're in, the processes vary. I've listed some on screen. And the important thing is that SYCL SC needs to be compatible with these processes. One of the key components of a safety critical process is coding guidelines. I've put some examples on screen again, and SYCL SC needs to be compatible with these. So digging into this just a little bit more, the SYCL SC exploratory forum came up with 3 philosophical tenets for SYCL SC. The first is that SYCL SC needs to enable predictable applications. And by that, we mean that the applications need to be predictable in their execution time, in their resource usage, and in the results that they produce. And this improves compatibility with a safety critical use case. Secondly, SYCL SC needs to streamline functionality of the SYCL API. And by streamline in this context, what we really mean is that if SYCL gives you 2 ways of doing something, SYCL SC might only give you 1. And that again reduces the certification overhead and improves compatibility with safety standards. And thirdly, SYCL SC is trying to specify more comprehensive error handling and to bring some more precision into the various ambiguities and undefined behaviors in the SYCL specification. And again, this helps compatibility with a safety critical use case. So the key in this slide is that these 3 tenets are first order priorities for SYCL SC. They are much lower on the list of priorities for upstream SYCL. So now that I've tried to tell you a little bit about what SYCL SC is, it's also important to note what it is not. In the last couple of slides, I've used the word compatible, and I've said that SYCL SC tries to be compatible with various processes and guidelines. And that term compatible is quite deliberate here because there are a number of things that SYCL SC will not do for you. First off, SYCL SC will not tell you how to implement a safe application. Just because you use the API doesn't mean your application is safe. And there are a number of reasons for this, but a lot of that comes down to context. Whether something is safe is entirely dependent on the context where you use it. And since SYCL SC doesn't know your context, it can't make the thing safe. Secondly, SYCL SC will not tell you how to implement a safe runtime. Just because you implement a specification doesn't mean that your implementation is safe. And again, this comes down to the context where you're operating and the processes you're following. Thirdly, SYCL SC cannot tell you how to apply any specific industry process or standard. And fourthly, the working group isn't going to produce any certified tools or runtime or any other code. But the small asterisk on that last point is that the SYCL SC specification will probably contain code snippets, and the working group will need to ensure that those code snippets are certifiable. So to summarize this slide, SYCL SC intends to be compatible with someone writing a safe application, but SYCL SC can't make that safety happen on your behalf. You still need to do the legwork to make the software safe. Right, so that's the background on SYCL SC, and now I'll give you a brief overview of what the exploratory forum has been up to. So the way I think about the SYCL SC process is it's a lot like this funnel. And we started off with a lot of ideas, and we kind of chucked them in on that end, and we're hoping that the 1.0 specification comes out on this end. And the way this started was a year ago, engineers from Core ABI and CodePlay started the exploratory forum. And this one was an open invitation to all interested parties to come and present their requirements and join the discussion. And the initial task for the exploratory forum was to put together an unfiltered wish list of potential SYCL SC requirements. And there were really three different goals to this. The first goal was that obviously from CodePlay and Core ABI's perspectives, we felt that there was very much a need for something in the safety critical software stack that looks like SYCL, but we needed to speak to companies that might end up using SYCL SC down the line to see if they thought there was a need. Otherwise, there's no target audience for the specification. Secondly, it was important to understand the priorities of the various companies involved. So if one company says, this feature here, it's really important to us, and another company says, that feature, that's not important, but this one is, then that's very valuable information to the working group because it helps define the priorities of the standard. And we did have a few conversations like that. And finally, it was important to identify any other requirements. So from CodePlay's and Core ABI's perspective, we kind of thought we knew what was needed, but we still needed to make sure that we hadn't missed anything and get other opinions. Right, so the exploratory forum produced this wish list, and then there was an extended period of narrowing down the wish list to a set of coherent requirements. And this involved quite a lot of discussion. And it's really this list of requirements that became the justification for a new standard. Because what it's saying is that there's this thing called SYCL. There are all these companies that want to use something like SYCL, except they have these extra requirements that are beyond the scope of SYCL. So the requirements became the core of the statement of work, which was submitted to the Kronos board and approved. And at that point, the working group was created. So today we're kind of there on the graph, just at the beginning stages of the working group. And at this point, I need to give a shout out to Ken Wenger from Core ABI and Verena Beckham from CodePlay for being co-chairs of the exploratory forum and making this whole process happen. Okay, so now that I've talked a bit about the big picture activities of the exploratory forum, I'm going to drill in a little bit into some of the more technical topics, just briefly. And the first of these has to do with the scope of SYCL SC. So for me, going into the exploratory forum, I was anticipating a lot of what I would call the usual suspects of safety critical software. So whenever someone says C++ and safety critical in the same sentence, someone will pipe up and say, so what are you going to do with C++ exceptions? And we did have a lot of discussions around those topics. But what was more interesting to me, in a way, was the the wish list items that I wasn't anticipating. And I've put a few examples on screen. So we had some parties coming into the exploratory forum and saying that, well, what they'd really like to do is to be able to access accelerators. Or what they would really like to do is execute stuff on the CPU. And what they would really like is to have a hardware agnostic API. But then we also had some parties saying that looking at the safety critical software space, there are a lot of engineers who are used to writing safety critical code in the C language. So maybe we should be thinking about a C API. Or alternatively, there are languages like Rust, which offer better memory safety guarantees than C++. So maybe we should be thinking about a Rust API. And these kinds of wish list items led to some extended discussions in the exploratory forum. And the reason I pull these examples out is because it seemed like these were very much reflecting the broader discussions that are happening in our industry at the moment. So I guess it kind of shows that what's happening out there is also relevant very much in the safety critical space. But yeah, so the exploratory forum spent a lot of time discussing these topics and then eventually worked out this principle of SYCL SC, that SYCL SC intends to minimize divergence between SYCL and SYCL SC. And this works out in two ways. First off, the exploratory forum decided that features that are essential to SYCL, that is the things that make SYCL into what it is, don't need to be called out in the SYCL SC statement of work because SYCL SC already is SYCL. And then on the flip side, features that would substantially diverge SYCL SC from SYCL are excluded from the scope of SYCL SC for the time being. So the way this gets applied to these wish list items is that the first three, access to accelerators, well, that's what SYCL is designed to do. CPU execution, SYCL already has a host execution model. Hardware agnosticism, SYCL is deliberately designed to be hardware agnostic. So these first three wish list items are already what SYCL does. And the final item, other language front ends, this would represent a substantial divergence from SYCL. So the exploratory forum decided that this is a question for the SYCL working group, not for SYCL SC. And if the SYCL working group decides to take that on, obviously SYCL SC will pay very close attention to that. But the conclusion to the slide is that we had these wish list items, we had very extended discussions around them, but none of these are in the statement of work. Instead, what they did was they contributed to the discussion and helped the working group understand, or helped the exploratory forum understand better what the scope of SYCL SC should be. So that was more of a broader technical observation. And now I'll pull out one specific technical issue, which is dynamic memory. So going back to the SYCL SC funnel, we had some parties coming into the exploratory forum saying that since SYCL is a C++ API, it's quite high level. Higher level APIs benefit from dynamic memory. So what they would really like to see is dynamic memory in SYCL SC. And we had other parties coming into the exploratory forum saying that SYCL SC is a safety critical API. Safety criticality and dynamic memory don't mix very well, so SYCL SC should have no dynamic memory. And you can kind of see how these two wish list items are just a little bit at odds with each other. And the key here for the exploratory forum really is that for a lot of people, they see these two different requirements, and it's very easy to kind of freak out and go running for the hills in a way. And for better or for worse, that wasn't really an option for us in the exploratory forum. We actually had to make progress on this topic. And the key to doing that is to cut through the fear, uncertainty, and doubt, and to really ask the question, what is it precisely that's bad about dynamic memory for safety critical systems? And the answer really is, it's quite simple. It's non-determinism. Digging into that just a little bit more, the issue is that dynamic memory either uses malloc directly, or uses something that relies on malloc, or uses something that looks a lot like malloc. The problem with malloc is that it starts in user space, it crosses into the operating system, and that crossing into the operating system takes an indeterminate amount of time. When malloc is operating in the operating system, it takes an indeterminate amount of time to find the memory that you need. And finally, malloc is allowed to return no. So it's allowed to tell your application, I couldn't get the memory you asked for. And all of these things are bad for safety critical applications because safety critical applications have very strict deadlines. And if deadlines can be missed in unpredictable ways, then it makes it very difficult to certify the application. So the key really is that the problem isn't dynamic memory as such, the problem is non-determinism. And it's this kind of discussion that the exploratory forum had to work through. And this is also a topic that I've done a fair bit of research into. And the short version is that you can get something that looks a lot like dynamic memory, but do it much more deterministically. Maybe the easiest solution is to ensure that all the calls you make to malloc happen before your application enters a time-critical phase. So all the non-determinism is still there, but you prevent it from affecting the safety of your application. A kind of second halfway solution is not to call free. And this avoids most of the complexity around malloc because you don't have as much memory fragmentation. But this is really only appropriate for some types of applications. In some contexts, it might be sufficient. Another solution is to use object pools. This is where you look at your application, you look at all the different types of objects your application is using, you figure out what the maximum number of each type of object is that you need simultaneously. You allocate all those objects upfront in pools. Then when your application needs one of the objects, it takes it from the pool. When it's done with the object, it puts it back. And this is the solution that IWOCL SC uses. And finally, it's possible to use stack buffers instead of buffers on the heap. So you create a buffer on stack, and you create your objects in that buffer. And there are going to be any number of other solutions and permutations on these solutions. But the key takeaway here is that it's possible to approximate something like dynamic memory, but to do it in a much more deterministic way. So going back to the SYCL SC funnel, we had these wish list items. We should have dynamic memory, or maybe we should have no dynamic memory. What the statement of work ended up saying was that SYCL SC needs deterministic memory management. And I think this is an interesting topic in and of its own right, but it's also a very helpful case study in the types of issues the exploratory forum had to address and the issues the working group will need to address going forward. And the key to these is to try to cut through the uncertainty and the knee-jerk kind of fear reaction and to understand what the underlying safety concern is, and then to identify possible solutions. And then it'll be up to the working group to make changes to the SYCL spec so that SYCL SC is compatible with these solutions. And there's that keyword compatible again, because as much as possible, it's important that SYCL SC doesn't mandate a specific solution when that can be avoided, and instead leave it up to the implementers to decide a solution that's appropriate for them. All right, so let's conclude. I've told you a little bit about what safety criticality is and why the need for SYCL SC exists. And I've talked to you a little bit about what the exploratory forum has been up to and shared some technical details of that. So if this looks interesting to you, if you think your company might want to implement SYCL SC in the future, or maybe you'd like to use SYCL SC in the future, then please join the working group. We're always looking for more people to join. At this stage, the working group is only open to Kronos members, so you will need to join Kronos. If that's too much of a barrier to entry, we're also looking into setting up an advisory panel that will be open to non-Kronos members, and this will be a chance to discuss ongoing requirements for SYCL SC. This isn't happening yet, but if you're interested, please get in touch. We'll let you know when it gets off the ground. And if that's also too much of a barrier to entry, just get in touch with us and talk to us. If you have thoughts on SYCL SC, if you have questions, if you've used C++ in another safety critical context, we're always happy to have a discussion. I'll leave our contact information up there. This takes me to the end of my slides, and I think I might be at time. So questions may be over dinner.
Yep, thanks for the talk. We've got a few minutes for questions. Any questions for Eric on?
So Leonidas just gave a talk. Are you guys in SYCL SC or are you outside? Like, what is?
We'll be joining, but we have to figure out the legal.
Okay, so you haven't joined yet.
Not yet.
Okay, I was just curious because it just occurred to me. I wanted to ask that question. So that's it. Actually, the question was more for Leonidas.
I'm glad he's here because I'm not sure the NDA allows me to answer that.
Given safety critical has been a C++ thing for a while probably, are there a lot of things that you can take from existing work that they've done to help form this SYCL safety critical spec or whatever it becomes?
I think there's a lot of relevant stuff out there. I think it needs to happen kind of on a careful step-by-step basis because there's a lot of talk as to what safety means for C++ in terms of language design. And sometimes that's relevant for safety criticality, and in some cases it's not. So if you're a language designer, when you talk about safety, what you care about is type safety, memory safety, and those things. When you work with functional safety and safety critical systems, you're more concerned with the non-determinism. Sometimes those two things support each other, but sometimes they can be at odds, especially if your code is trying to do runtime checks and that kind of thing.
Thanks. So speaking from experience, implementing a SYCL implementation can be a huge amount of work. So my question is, do you expect that there might be new independent SYCL SC implementations, or is the idea to kind of take existing SYCL implementations and hope that somebody would adapt them to conform SYCL SC, assuming SYCL SC is closely related enough to SYCL?
I mean, it's a very good question. It's very difficult to answer because it touches on the business plans of various parties, and most of those I'm not privy to. I think as a minimum, what we're very interested in doing is having an open, non-certified implementation of SYCL SC that people can use to play with and understand the API. Who would be implementing SYCL SC in a safety certified way, following safety processes, what their business model would be? I think that question is still quite a ways away, and I don't have a good answer to that.
Thanks.
Okay, with that, we'll thank our speaker. Thanks.